Alright, I'm Jordan Anderson again, and I just ate an entire Little Caesars pizza. So, before I pass out, I'm going to go over one of the easier and shorter lessons in pre-calculus, which would be the values of the 6 trigonometric functions, and I'm maintaining my beautiful penmanship. So first of all, like we covered earlier, sine is the ratio for the opposite side of a triangle over the hypotenuse. Cosine is the ratio for the adjacent side over the hypotenuse. Tangent is the ratio for the opposite side over the adjacent side. Cosecant, this is a new one, is the inverse of sine. So it's equal to the hypotenuse over the opposite side, or simply 1 over the sine of theta. Secant is inverse of cosine. So it is equal to the hypotenuse over the adjacent side, or 1 over cosine of theta. Cotangent, you can probably guess, is the adjacent side over the opposite side, which is also equal to 1 over tangent of theta. Now, in case anyone's confused by what's the adjacent and what's the opposite side, say we have a triangle. We're going to pretend that this is a right triangle, even though my drawings are awful. So, we'll say this is theta. The adjacent side would be the side that is not the hypotenuse that is closest to theta, so right here. The opposite side is the side opposite to the angle. So this would be the opposite side. Then, of course, the hypotenuse is the longest side of the triangle. That is a terrible H, but let's continue. So, with these ratios, you can pretty much find out all you need to know about a triangle if you're given only a few measurements of it. So, let's do an example. Let's say we have a triangle. Also, pretend this is a perfect right triangle. Let's say we have, 40 degrees. So 90 plus 40 is 130, and we know there are 180 degrees in a triangle. So 130 plus 50 degrees would equal 180, so this should be a reasonable triangle. And let's say that this side, let's take the hypotenuse, is 7. So, with our 6 ratios, we could solve for this side right here. We'll call side A, and this side B. So to solve for side A, we know we're using the opposite and the hypotenuse. We know that sine of theta is equal to A, the opposite side, over 7. So, we can take the sine of theta, which is, or the sine of 50 degrees in this case, so 0.766 after 0.766 is equal to A over 7. So, we can then multiply both sides by 7, giving us 5.36 equals A. So, now we've solved for this side. Now, we still have to solve for B. Let's do it using cosine this time. So, we know that we know 7 is the hypotenuse, and cosine is equal to the adjacent side over the hypotenuse. So, we'll take the cosine of 50 degrees is equal to B over 7. So, the cosine of 50 degrees, using our calculator, is 0.64. Now, we can multiply that by 7. Oh, first, let's finish this equation. So, 0.64 equals B over 7. So, we can multiply both sides by 7 to get 4.36 4, 9, which is equal to b. So, using the ratios, you can solve for just about any aspect of a triangle if you have any aspect of a right triangle. These only work for right triangles. But so, it works. You can find all you need to know. Now, if we had one of the sides instead of the hypotenuse, we would do the same thing, but use one of the other, use the inverses of these ratios in order to solve it. And I believe that's all you need to know, and I can feel the Little Caesars going to my heart, so that's all for now.